Okay, question number 1. We have f of x is equal to 2 power x. So we need to find f of 1 and f of negative 1. So f of 1 is going to be 2 to power 1 because x we plug 1, yes, and f of negative 1 it's going to be 2 to power negative 1. Now which will be 1 over 2. Let me explain why we get 1 over 2. So first of all, the rule is a to power negative x is equal 1 over a to power positive x. Okay, so if I have 3 to power negative 1, it's equal 1 over 3 to power positive 1, or 1 over 3. And if I have negative x in denominator, 1 over a to power negative x. So we're gonna flip it, the fraction, which means denominator will come in numerator with positive x, and numerator come to denominator. The same thing we can say here, a to power negative x. So with denominator we can take as a 1, right? Because there is no denominator, that means 1. So as you can see, numerator comes to denominator, and denominator comes to numerator, and numerator comes to denominator with positive 1, positive sign. The same thing here, denominator comes to numerator with positive x, and numerator comes to denominator. So you just flip the fraction. Therefore, 2 to negative 1 I can represent as a 2 over 1, right? And because we have negative 1, you just flip it and you get 1 over 2. Okay? So next one, question number 2. We have f of x is equal 4 to power x. And we need to find how much will be f of negative 5. So f of negative 5 will be 4 to power negative 5, and that is 1 over 4 to power positive 5, which is going to be 1 over 1024. Okay? And f of, okay, we don't have positive 5, so that's good. All right. Next, question number 3. G of x is equal 1 over 7 to power x. So we need to find f of negative 1, and that is equal. So f of negative 1, so we plug x as a negative 1, 1 over 7 to power negative 1. Remember here what I said, we need to flip the fraction, so 1 over 7 will become 7 over 1, which is 7. All right, number 4, f of t is equal 15 to power t. Okay, let me see what we need to do. So in this 15 to power t, it passes through points. Negative 1, we need to find what y will value will match, and then 0, we need to find which value will match, and 1, also we need to find what value will match. So how are we going to do it? So f of negative 1, it's going to be equal 15 to power negative 1, right? Since 15, it's a 15 over 1, I can put over 1. So if I flip the fraction, it's going to be 1 over 15. Yes, which means it's going to be here 1 over 15. For point -1, the coordinate is going to be 1 over 15. Now let's plug 0. F of 0. F of 0 is equal 15 to power 0. It's going to be 1. So it's matching here 1. And for this one, let me move over here. So it's going to be f of 1 equal 15 to power 1, which is 15. And the answer here is going to be 15. Okay? Next, moving to graphs. So we are going to graph question number 5. We are going to graph y is equal 4 to power x. Okay, since we are graphing first time this exponential graph, we can build a table. With at the one point we take from negative x area, and then we take 0, and then 1 point from positive x area. Let's see. I'm taking -1, taking 0, and taking +1. When we have -1, we get 4 to power -1. It's going to be 1 over 4, yes? When we get 0, then it's going to be 1, because any number to power 0 is equal 1. Okay? Next, when we take power 1, 4 to power 1, it's going to be equal 4. Okay, let's draw the graph. Well, much better. So x we have, this is 1, 2, 3, 4. So this is -1. This is +1. Okay, so when we have -1, y is equal 1/4, which is going to be half of right here. And when we have 0, x is 0, we have here 1. This is next point. And when we have 1, y is equal 4. So the graph is going to look like this. Okay, by the way, when our base is greater than 1, then the higher x, the closer it's going to become to y. Let's say this one, let me see. It's going to be, for example, 5 to power x, and then it's going to be 6 to power x, and so on. Okay? The higher the base is, it's closer get to y, the axis. Okay, question number 6. Okay, we need to graph y is equal 1 over 5 to power x. All right, let's do this one also. So this is x, this is y. When x is -1, y is equal 1 over 5 to power -1, which will be 5, right? Because we flip it. When it's 0, it doesn't matter what base it is, it's going to be 1. And when x is 1, we are getting 1 over 5. Okay, so okay, so how it's gonna look like? Let me see. We need to go 5 up 5. 1, 2, 3, 4, 5. This is 5. Okay, and x is negative 1. This is negative 1. So this is this point. And then when we have x is 0, y is equal 1. And when x is equal 1, y is equal 1/5. Let's see what's happening. The graph is going to look like this. Okay, it never touches x-axis, but it's running to x. So this is 1 over 5 to power x. Okay, question number 7. What do we have here? So practically, when our base is fraction, then graph is going through, going opposite way, which means you are flipping this, see, let me see. You take the 5 over x, 5 to power x, let's say. Yes, and take it and flip it on the other side across, and you flip across the y-axis. All right. All right. Question number 7. 4 to power negative x. Y is equal 4 to power negative x. It's the same we think. 4 to power negative x. I'll explain to you. So we know it's going to go through 1, right? Because x to power 0 is going to be 1. So what I'm going to do, 2 ways. Instead of now building a table, if you wanted just to sketch, show how it will look like. So you are building, showing 4 to power x, which is going to go like this. Hold on. Let me use the other thick color, it's working better. Okay. And this is 4 to power x. Okay. And the 4 to power negative x, it's gonna look like symmetric. So you flip it. Okay. Well, let's say it's a little bit like this. So this will be 4 to power negative x. And you can say, yeah, that's same like 1 over 4, indeed. Because 4 to power negative x, if I flip it, I get 1 over 4 to power x. So it's the same graph, they are equal. just like in question number 6 I showed you. Unless you want to go by table, you can go by table, but just to draw the sketch, then that's result. Moving to question number 8. So f of x is equal 2 to power x minus 2. Okay, let's see how we're gonna work with this. So first, I'm going to build 2 to power x. This I'm going to build, okay? So this is my graph, and then I'm taking this one, so 2 to power x, it's gonna look like this. If this is my 1, so it's gonna go like this. Now, this negative 2, that's a change of y, okay? Which means I'm taking the entire graph and moving down by 2. So 1, since here we have 1, yes, minus 2, it's going to be negative 1, yes? So this will be negative 1. So x is moving here, and the graph will come down by 2. See, here is 1, this is 2, yes? And the graph is moving down parallel. Like this. Okay? And this is going to be positive 2 to power x minus 2. This will be negative 1. Negative 1 because we moved by 2. 1 and 1. Okay. Now from here also we need to find domain. Remember what I said, when graph is uninterrupted, then it's going to be from the x is going to be negative infinity, positive infinity. How about range? Range is going to be, so it started from negative 2, because, hold on, let me make it clear. 1 second. So it's gonna be better seen. So this is negative 1. Yes, and this one is gonna be negative 2. Okay, so and practically this our 0, where our 0 is, if we move down by this negative 2, it will come right here, minus 2. So range is going to be from negative 2 to positive infinity. Okay, question number 9. 3 to power x plus 1. Number 9. F of x is equal 3 of 3 to power x plus 1. Now, while here we had shift on y, Now here, because it's a change of x, we're going to have shift horizontally the right of left. The thing is, on every single graph, be it exponential graph, be it logarithmic graph, or be it a quadratic, the parabola, quadratic equation graph, change of x always going opposite direction. Okay, if x is plus 1, then we're moving to negative 1. Why? Because if I put x plus 1 is equal 0, x is equal negative 1. But in the case of x at the y, there is no such thing. It's going to change directly the way it's written. Okay? So, let me take the graph. Okay, so what we are going to have here, x plus 1. Let's say if this is my 3 to power x, this is 0.1, right? Because every graph, it's going to be going through 0, because if x is 0, 3 to power x, it's going to be 1, yes? Let's say this is our 3 to power x. Now we need to move by negative 1, correct? So if this is 0, 1, coordinate x is 0, it's 1, then if I move to by negative 1, then this point will move here, right? This point will move to here. Let me move this one. And clean this one. So what do we get? It's my point shifted by negative 1 because 0, because x shifted and my x is 0 here. Yes, this 0, correct? Then it's going to shift to, we're going to have negative 1 and 1, because this is negative 1 and this one we have it already here. So the graph, it's gonna look like this. Okay, and this is our point. So this will be 3 to power x plus 1. Okay, next one. Question number 10. F of x is equal negative 4 to power x plus 3. Okay, well, let's see how we're gonna build this graph. So first, we are going to move the graph 4 to power x plus 3, right? So if this is my 4 to power x, this is 0, 1, this point, 4 to power x. So if I move by negative 3, right? If I move by negative 3, it's going to be, this is 1, it's going to be 1, 2, 3. So this point is coming here. So it's gonna be, the graph is gonna go like this. I wanna do also here dashes because this is not our final answer. Dashes. So this is 4 to power x plus 3, and this point is, negative 3, 1. Yes? This point, negative 3, 1. Because of this plus 3, we shifted by negative 3. Now it's time to deal with negative 4. For negative 4, what we're going to do, we're going to take this green one, 4 to power x plus 3, and flip across the x-axis, which is going to be like this. So it's going to go through same point. So instead of negative 3, 1, it's going to go negative 3, negative 1, this point. So the graph is going to go like this. You know, let me, I think it should go, 1 second, let me draw it precisely. So this green, it's going to go like this, parallel. Yeah. Which means this one is going to go like that. Okay? And this is going to be our negative 4x2 plus 3. That is going to be my graph. So you build 4 to power x plus 3 and flip it over across the x. And that will be your negative 4x to power x plus 3. Okay, next we need to find a domain, which domain is clear. There is no interruption, negative infinity, positive infinity. And the range is going to go from where? Since it's approaching here to 0, right? So our x-axis is going to stay. Then it's going to go from 0, and it's going down to negative infinity. Yes, our range, because it's our y. See, it's going down. The graph is going down. So it's going to go to, well, hold on, negative infinity, 0. Since we have negative infinity, first come negative and then positive, right? Because numbers growing from negative to positive. Negative infinity to 0. All right? Question number 11. Okay, what do we have? We have here question number 11. F of x is equal 6 to power negative x. So 6 to power negative x, remember, we either can build by point 1 over 6 to power x, or as a sketch also, since it's a fraction, we know that it's going to go. So if my this is 1, 0, 1 point, right? Because x to power 0, x is 0, 1 of 6 to power 0 gonna be 1, correct? If this is my 6 to power x, then 6 to power negative x is gonna go like this. Symmetric. So 6 to power negative x. Okay, or the other way, it's just 1 over 6. So, and you know that 1 over 6 is going to go like this. You can get 3 points, but as a sketch, that's what you have. Okay, question number 12. We have f of x is equal 2 to power x plus 4 plus 3. Okay, 2 to power x plus 4 plus 3. Now here we have in the shifting, a horizontal shifting, and we have vertical shifting also. Okay, let's see what we are going to do, how we're gonna work with this. Okay. Okay, so let's see. Our horizontal shifting, it's going to be -4, right? The graph, let's say, let's put the graph. 2 to power x. Okay. Two to power x. This is our original graph, 2 to power x. Now, x plus 4 to power x plus 4 and then plus 3. So we said this is plus 4, it's a horizontal shifting, which is going to go -4, and plus 3, it's going to be vertical shifting, right? So what we are doing, so it's going to shift to up 3, this is 0, oops, this is 0, 1, right? This coordinate. So we are going to go up by 3. Yes, this is 1, this is 2. This is going to be 3. So 0, 1. And we move from here. It's going to come to all the way to 3. Right? Shifting by 3. And going negative by 4. Oh, wait a minute. Let's do it positive this time, so it would be interesting. We did already positive. Let's do negative. So -4, that means I'm going +4, which is going to be 1, 2, 3, 4. It's going to be +4. And moving +4. Okay. +4, it's going to be like this. Okay? All right. Which means this is going to be my, hold on, let me make it more clear so we can understand. 1, this is 1. So I'm going 1, 2, 3. Let me move here, which is going to be 4. And this 3 actually is becoming our new x, because we shifted by 3. See? 1, 2, 3. And it's going through 4. And if I move this here, I want you to understand what I did. Because here I have 1, right? This point is 1, and I needed to move by 3. 1 plus 3, it will be 4, correct? That's why we moved by 4. So, and since my x is also was -4, then I go +4. Then this coordinate is going to be 4 and 4. Okay, so this way, then my graph, it's gonna go, this is gonna be my, since this is my new x, it's gonna run to my new x, and through this point, it's gonna be parallel and coming to this point. Okay, now let's see domain. So it's gonna be negative infinity, positive infinity. And the range, it's coming from this point, right? It's running to here. This is our free, correct? So it's gonna be from free to positive infinity because it's running up. All right, question number 13. Question number 13. What do we have? F of x is equal 3 to power x plus 2, okay, minus 4. Or let's see what we're gonna do here in this case. So 3 to power x, so 0 and 1, right? 3 to power x. Now, what we're gonna do? We are going to move down by 4. So from here, moving down by 4, it's gonna be 1 minus 4, it's equal negative 3, right? So we're gonna move 1, 2, and 3 right here. So it's the point is gonna be 1, 2, here. Negative 3. Right? So this point moving to down to this point. But we have also plus 2, which is going to go towards minus 2. 1 and 2, negative 2. Which will come down here. So practically this point will move to this point, okay? Because we have shifting down by 4. From 1 minus 4, it's going to be negative 3. And shifting to the left, x, negative 2. So where will move my x practically? My x will go down to negative 4. Okay, this is going to be my x. Because, why? Because we have 1 down, right? 0. So if it's negative 3, 1 down, it's going to be negative 4. Okay, which means the graph is going to run like this. It's going to go parallel and come to, or maybe I can do a little bit better job with this. Okay. All right. So this is going to be 3 x to power x plus 2 and all this minus 4. All right. Question number 14. Let's do domain also. Domain and range we need to do. So domain, it's going to be again negative infinity, positive infinity. Range is starting from where? You're right, negative 4. Negative 4 to positive infinity. Okay, question number 14. F of x is equal 1 over 4 to power x and minus 7. Okay, So let's see what we're gonna do here. So what do we have? We have no shifting of x, right? Which is going to be 0. We don't have x plus whatever. So we have only x, but we have only vertical shifting, minus 7. So what I'm going to do, I'm going to build 1/4. So if you need, you can build table. So I'm going approximately. All I know it's going to go through this coordinate 0, 1. So if you build the table 1/4, or you can build right away by point 1/4 x minus to power x minus 7. Either way you can do it. But I am sketching now 1/4 to power x and then move down by 7. That's vertical shifting. Negative 7. So 1 minus 7, it's going to be negative 6, right? So we're going to go down to 1, 2, 3, 4, 5, 6. It's going to be right there. Okay, this is going to be our negative 6, correct? Which means this the x-axis is going to move to negative 7. So it's going to run to negative 7, right? All right. We don't have any horizontal shifting because we have just x and not plus x plus any number. Therefore, I'm taking this at 1/4 to power x and just move down to go through points through negative 6, which is going to be parallel. Like this. And this is 1/4 to power x minus 7. Now, if you don't wanna move like that, you can build by points. So let me show you by points. If this is x, this is your y. So if x is equal negative 1, then y is going to be 1/4 to power negative 1 minus 7, which is going to be 1/4 to negative 1, it's going to be 4, right? Minus 7, it's going to be 3. So when your x is equal negative 1, let's say this is negative 1. Okay, so it's going to be 1, 2, 3, which means my sketch is going to go through this point. This point. So it's going to go like this. Yeah? Something like that. Precisely. Next is when it's 0. 1/4 to power 0 minus 7, which is going to be 1/4 to power 0 is 1 minus 7 is going to be negative 6. Here we have this one because we calculated, right? 0, negative 6. And we have positive 1. It's going to be 1/4 to power 1 minus 7, which is going to be 1/4 minus 7. It's going to be negative 6 and 3/4. Now, whoever doesn't know how to subtract fractions, open my playlist Basic Math and you can find there Subtraction of Fractions. So when x is equal 1, let's see if we have it right, is equal 1. So we need to take negative 6 and 3/4, which we get it. When coming down, it's 6 and a little bit lower, yes, we get it. Negative 6 and 1/3, 3/4. Okay? And that is the two ways to do that. Okay, now domain. Obviously negative infinity, positive infinity. Range is gonna start from where? That's right, negative 7. Positive infinity. Question number 15. So, we are solving equation 9 to power x is equal 3. How are we going to solve? We know one thing, that if I have same base, a to power x, let's say, is equal a to power 3. If my base is the same, both of them are a, then I can say that x is equal 3. Then exponents are equal. Now here I have base 9 and here I have 3. What my goal is going to be to bring to the same base. So 9 to power x I can represent 3 to power 2 x is equal 3. Now 3 to power 2 to power x is going to be 3 to power 2x, because power to power, a to power m to power n is equal a to power m times n, which is 2 times x will be 2x, and that is equal 3 to power 1. Since bases are the same, then I can insist that 2x is equal 1. And from here, x is equal 1 over 2. Okay? Question number 16. Five over 3x is equal 27 over 125. Okay, so 5 over 3 x is equal 27 over 125. Let's see if I can bring two same base. So 27, 5 over 3 x equal 27. Can I represent 3 to power 3? Yes, because 3 times 3 is 9, 9 times 3 is 27. 125 is 5 over 3. Yes? Okay. Now, I can write down 5 over 3 to power x is equal. I can take this power 3 out and get 3 over 5 to power 3. Okay. Well, it's interesting. On one side, I get 5 over 3. On the other side, get 3 over 5. What I can do? Remember, if we have negative exponent, we flip the fraction, yes? So either I can take put x negative, or I can put 3 negative and flip the fraction. I'm flipping the 3 over 5, put negative with 3. Why would I want to work with negative x, right? So I put 5 over 3x is equal 5 over 3 negative 3. Make sense? Since we have base the same, then we can write down that x is equal negative 3. Question number 17. Question number 17. 3 to power 2x minus 7 is equal 9. Okay. Looks like 3 to power 2x minus 7. I can write down 3 to power 2. Base is the same, then 2x minus 7 is equal 2. Moving 7 on this side, 2x is equal 2 plus 7. 2x is equal 9. And dividing by 2, x is equal 9 over 2. Question number 18. e to power 10x minus 1 is equal e to power 8 to power x. E, it's a mathematical meaning. E is has its own value, and it's widely used in the economical growth. So what I can do here, e to power 10x minus 1 is equal e to power 8x, right? Because we multiply 8 times x. Okay, so e and e I can drop, so I get 10x minus 1 is equal 8x. So moving 8x on this side, so I get 2x, right? 10x minus 8x, 2x is equal, moving this one on this side, become positive. So, and x is equal 1 over 2. Next, question number 19. 64 to power 4x is equal 16 to power x plus 3. Okay, well, let's see. So I need to bring to common same common base, right? 16 to no power, whatever power I raised, I will never get 64. But both of them I can bring to power 4. So 4 to power 3, it's 64. Power 3 to power 4x is equal 16 is a 4 to power 2 to power x plus 3. So what do we get? 4 to power 12x, because 3 times 4x, right? And here I'm getting 4 to power 2x plus 3, because I distribute and by x and by 3. Okay, oops, plus 6. It's saying distribute and not writing down. Okay, 6. So since we have 4 and 4, we can drop this base and we have 12x is equal 2x plus 6. So 2x moving on this side will be negative 2x. 12x minus 2x, 10x equals 6. And we divide by 10 here, by 10 here. It's gone. And x is equal. Okay, 6 and 10, let's reduce by 2. This is 3, this is 5, and it's equal 3 over 5. And the last question, question number 20. 81, 3x minus 3 is equal 729 x plus 2. Okay, well, this is getting interesting. 729, let me see how much it's gonna be. I know that 81 is a 3 to power 4, right? Because 3 squared is 9. 9 times 9 is 81. So 3 to power 4. To power 3x minus 3. Let's see how much it's gonna go. The 729. Let me take radical 3. Let me see how much it's gonna be. I don't see it. 729. Let me use calculator. 729. So 3 to power, let's say 6. How much will be? 729. Perfect. 6. Okay. So it's going to be 3 to power 6. x plus 2. Let me move this on the other side because all math I did on this side. Okay, and from here, what we get? Hold on, let me write down this way. Although that's not a mistake, but since you learn it this way, so might as well. So it's gonna be 3 to power 4 times 3x minus 3, and here equal 3 to power 6 times x plus 2. So since we have 3 and 3, we can drop and we get 4 times 3x minus 3 is equal 6 times x plus 2. Okay, 4 times 3x, it's gonna be 12x. 4 times negative 3 minus 12. Here gonna be 6x plus 12. All right, moving 6x on this side will become negative. Negative 12 moving on this side will be positive. So we get 12x minus 6x. We get 12 and plus the other 12. 6x is equal how much? 24. So we divide by 6. This is gone. This is 1 and 4. And we get x is equal 4. Okay, I'm done. And thank you for watching. See you in next video.